So here is a sample question. Cn is glucose, Dn is zinc 2 oxide. So carry out the following exercises on sample C and D. Record your observations and identify any gases involved. State the conclusion you draw from the results of each test. Now these are the steps. It goes like this. Put all of C in a test tube, stir thoroughly and add about 5 cm cube of distilled water and test with litmus paper. Add about 2 cm cube of Fehling solution to the resulting mixture and heat. So I will explain how to prepare Fehling solution later. Then over to D. Heat all portion of D. Sorry, that's supposed to be all. Heat all portion of D in a test tube. And the II says add about 5 cm cube of HCl and divide into 2 portions. To the first portion, add sodium hydroxide in drops and in excess, and the second portion, add ammonia in drops and then in excess. So go over to the result of it. So C plus distilled water. C dissolves to give a clear solution. So C is soluble in water. Now plus litmus paper, you find out that it has no effect on blue and litmus paper, telling us that C is neutral. Alright, so if we add Fehling solution to it, which I will explain how you prepare, and then you heat it. After adding the Fehling solution to it, you observe a brick red precipitate is formed, telling us that C is a reducing sugar. Glucose suspected. Alright, so glucose could be the CN that is being provided to us. Alright, though we'll have other reducing sugar that will react this way. Now over to D plus heat. D is your zinc 2 oxide. If you heat it, it changes from white to yellow when hot and turn to white on cooling, telling you that zinc 2 oxide is present. Alright, so if you go further to add dilute acid to zinc 2 oxide, take note zinc 2 oxide is insoluble in water, alright, but soluble in dilute HCl. If you add dilute HCl to it, it dissolves to give a colorless solution. So D is soluble in dilute HCl. Now if you divide it into 2 portions and then you add sodium hydroxide in drops, you have a white gelatinous precipitate formed. Alright, telling us the presence of aluminium ion and zinc 2 ion being present in it. So if you add SS to it, you find out that the precipitate dissolve also. Take note, gelatinous precipitate, that's why we are not adding lead, because lead does not give gelatinous precipitate. Then in SS, the precipitate dissolves, telling us that aluminium and zinc 2 ion is present. So D plus ammonia in drops, a white gelatinous precipitate is formed. Aluminium ion and zinc 2 ion are present. Then in SS, the precipitate dissolves, is soluble in SS, confirming the presence of zinc. This confirms the presence of zinc in it. I will go over to demonstrating the practical now. Alright, so here is how you prepare your Fehling solution. This is Fehling A. Measures 15 cm cube of Fehling A with a measuring cylinder. So this is Fehling A, 15 cm cube into your beaker. Then you measure this Fehling B. You also measure 15 cm cube of Fehling B into your beaker using the measuring cylinder, and you mix thoroughly. So this is your Fehling solution. Okay, you can store it in your reagent bottle for further usage. Alright, this is glucose. We want to start with glucose first. So we'll take a spatula full of glucose I'm using a boiling tool so that you can see it very well. Okay, so you make a cure solution of it. You stir thoroughly to ensure it dissolves. Now I'm testing with red litmus paper. You observe that it is neutral to it. With blue litmus paper, likewise, it is neutral to it, telling you that CN glucose is neutral. Now add 2 cm cube of the Felling solution to it. That's about 2 cm cube of it, and then you eat it. All right, stir, ensure it mixes properly. So these are buzzing, but now you observe a brick red precipitate being formed. As it is, I believe you can see it being formed. This confirms the presence of a reducing sugar. This is a brick red precipitate. Okay, we'll go back to zinc 2 oxide. We take a spatula spoon of it into our boiling tube. Then you eat. You observe that it is yellow, pale yellow when hot, and also on cooling change to white. You can see it yellow when hot, and then when cooled, this yellow when hot, when cooled it changes back to white. All right, so we'll add dilute acid to it, and then this dilute acid added to zinc 2 oxide, and then you stir. You find out that it dissolves well to give a clear solution. So I'll divide now into 2 portions. This is the first portion. I'll add sodium hydroxide in drops. It will give you a white gelatinous precipitate. Just where you can see the precipitate being formed. Then in excess, the white gelatinous precipitate dissolves to give a clear solution, telling us that zinc or aluminium could be present in it. You can see it now. We have a clear solution. All right. So we'll repeat this with ammonium. The other portion of it, we're adding it in drops also. So in drops, we have a white gelatinous precipitate being formed, as you can see. Then in excess, you find out that also it dissolves to give a clear solution. Wow. All right.